Among all the planets of the solar system, our Earth is unique, since it's the only one that has developed life. But what if we got a competitor? What if a second Earth appeared out of nowhere? Then there would be two different scenarios. The first is the destruction of both planets. The second has an unexpected but pretty logical ending. But let's start with the catastrophic scenario. The second Earth with the same conditions could only exist if it received absolutely the same amount of sunlight as our planet. The orbit that our Earth follows is perfect for getting the necessary amount of solar heat. If we were a little further away, the entire surface of our planet would resemble Antarctica. And if Earth were a little closer to the sun, we'd all live in a huge desert, inhabited by very few living beings. So, for the second Earth to be identical to ours, it would need to follow the orbit of our planet. Two massive objects can exist close to each other. The union of Earth and the Moon is a great example. But if the second object was as heavy and huge as our planet, there wouldn't be enough space for both of them. The gravity of two Earths would be a huge problem. The two worlds would collide because they would be pulled toward each other. This process would last for hundreds of millions of years. And in the end, the two planets would transform into one giant world. And their remnants would be flying around the newly formed planet, resembling the rings around Saturn. Or one of the planets would push the other out of its orbit. In this case, one of the Earths would hurtle toward the sun and burn like a match in its atmosphere. It's also important to remember that Earth is moving at a speed of 67,000 miles per hour at all times. This is more than 80 times faster than the speed of sound. And now, imagine two huge planets that are flying toward each other at such a speed. Even a microscopic organism living in the mouth of a volcano wouldn't stand a chance to survive the collision of two Earths. Even the Moon would be torn to pieces by the blast wave. But let's imagine that Earth's twin is following another orbit, somewhere between Mars and Earth. Even in this situation, people's lives would change forever. By the way, the theory that Earth might have a twin appeared long ago. Scientists of the past believed that the second planet could be hiding on the opposite side of the sun. Thanks to modern technologies in astronomy, we know this theory isn't true. Otherwise, our telescopes and other equipment would have already caught some signals from this planet. Scientists study space objects thousands of light years away from us, so they would definitely notice another world in the neighborhood. But anyway, let's imagine that the second Earth does exist, and we've discovered it recently. The entire field of astronomy and astrophysics will immediately receive hundreds of billions of dollars in funding. The study of Earth's twin will become a priority goal for people. Experts will put forward hundreds of hypotheses about what the second Earth looks like and what's happening there. The planet is almost at the same distance from the sun as we are. This means the weather must be the same there. Soon, scientists find out that Earth's doppelganger has liquid water and continents, but they aren't like ours. Their shapes and location are different. Most likely, life exists there too. But what is its origin? There's a hypothesis that life on our planet appeared thanks to amino acids brought here by a meteorite. It's highly improbable that the same thing happened to another world. Life most likely emerged there in a completely different way. Perhaps the fish didn't get out of the water on that planet, and the first intelligent creatures appeared in the ocean. These could be amphibians with scales and fins, or octopus-like monsters with huge tentacles. Fish on the second Earth could have come out of the water and grown limbs. But what if they didn't like walking on the ground? Then, this world might be inhabited by intelligent bird people. Or, life could have originated deep in the soil. Then evolution would create humanoid moles or highly developed worms. To find out for sure, scientists send a rover there. A similar mission to Mars was a success, so there shouldn't be any problems with this one. People on Earth are waiting. What will the rover find on the other side? It will take several years for the ship to get there. Strangely, 2 days after the launch, it returns. But wait, this is not our space probe! All this time, the inhabitants of the second Earth have been watching our planet too. At one point, they also sent a probe. It's made of the same materials as ours. It has a camera and a recording device. But people are worried because the rover looks similar to a mechanical spider. Can it be that giant tarantulas live in that world? Scientists understand that we need to communicate. We send our guests a radio signal with some information about our civilization. They catch this message and send their own. It contains strange symbols that resemble scratches. Linguists all over the world are trying to decipher it. Meanwhile, astronomers send the guests a recording of human speech. A few days later, our satellites catch a message from our space neighbors with their voices. Scientists are about to play the recording. The whole world is listening with bated breath, and it's a growl. A terrible and absolutely incomprehensible growl. It has pauses and an unusual rhythm, but it's nothing resembling human speech. The whole planet is panicking. All countries are preparing for an invasion. The most important thing now is to build shields to protect the planet. No one can decrypt the message. It's possible that our neighbors can't understand us either. People make a last attempt to establish some contact. We send a video to explain to our guests with the help of gestures and signs that we only want peace and collaboration. The answer doesn't take long to wait. Our satellite receives their video file. Scientists play back the recording, and it's shocking! We see dinosaurs in robotic suits! Life on the second Earth has been developing in the same way as on our planet. But the infamous colossal meteorite didn't fall there. Over millions of years of evolution, dinosaurs have become sentient. In the video, they're growling and pointing with their claws at the picture of our Earth. Then they start growling even more loudly, and is it laughter? The recording ends. People consider this the announcement of the invasion. Several years have passed. During this time, scientists have exchanged messages with dinosaurs several times, and it seems we're beginning to understand them. It turns out that the reptiles also want peace. They say that their planet was once inhabited by humanoids similar to humans, but a massive flood wiped them away. Dinosaurs managed to survive and evolve into intelligent beings. It will take many years before people set foot on their planet, and when this happens, humanity will feel relieved, realizing that we're not alone. But what if there was no intelligent life on the second Earth? People would also be happy. We would know that we'd always have another home. Perhaps we'd start exploring Earth's twin right away, or begin mining its resources to replenish ours. In any case, our lives wouldn't change immediately, because that land would be too far away from our planet. Dozens of generations would pass before people begin settling on the second Earth. Our homeland planet would be losing more and more resources, so everyone would want to move to a new world. In the beginning, only the richest would be able to do it, but with time, space travel would become cheaper. People would probably invest a lot of money to build a paradise on the second Earth. If this happened, we'd be visiting this world during our vacation to breathe fresh air and enjoy nature. In any case, the human population would grow. This means that sooner or later, the second Earth would become as loaded as the first one, and then people would start searching for a new home among the stars. By the way, if any life exists on a planet similar to ours, it's likely to look like octopuses. There's even a theory that octopuses came to Earth from some other world. Any animal has several evolutionary stages of development. For example, elephants and mammoths descended from one common ancestor 5 to 6 million years ago. Looking even further, almost all mammals evolved from one ancestor they shared with reptiles. Each species has been changing over millions of years. But not octopuses. They suddenly appeared on a family tree. From the point of view of evolution, squids would have to evolve into octopuses millions of years from now. But look, they're already here. Besides, octopuses are incredibly smart. Their genetic code is much more diverse than the human one. They may be visitors from another planet that is similar to ours. But of course, this is only a hypothesis.
What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock, because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life, It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O, you know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans, because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains, and every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped. The land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or super liquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact: all of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here.
Hop on! I've prepared a tour around Earth's fellow planets. Let's start with Mercury, the smallest planet in the solar system. During the day, the temperature on the surface of this planet can reach 800 degrees Fahrenheit, and during the night, it can drop to negative 290 degrees Fahrenheit. The temperatures here are so extreme because the planet has no atmosphere. Instead of it, Mercury has a thin exosphere. That's one of the reasons why Mercury is not habitable. The temperatures and solar radiation are too extreme for any organism to survive there. Now let's imagine there's a way to live on Mercury. Then what would life there look like? Mercury's surface resembles that of the Moon. Over time, meteorites left lots of marks on it. Unlike the Moon's surface, Mercury is grayish-brown. Now look up. The Sun on Mercury would appear almost 3 times as large as it does on Earth. The sunlight would be almost 7 times brighter. I wonder what type of sunglasses people would wear if we lived there. Can life appear on this planet in the future? Don't get your hopes up, it's very unlikely. Now, how about landing on Venus? You might think the hottest planet in our solar system is Mercury since it's the closest to the Sun. But in reality, this title goes to Venus. What is it that makes Venus boil? The biggest reason is its atmosphere. It's made up almost entirely of carbon dioxide. The atmosphere is so thick that it leads to the planet warming up non-stop. Basically, the gases in the atmosphere prevent thermal radiation from leaving Venus. So, the planet simply can't cool down. The water on its surface constantly turns into vapor. If the surface of Venus was food, then its atmosphere would be the microwave. That's why the temperatures in this world can go up to 870 degrees Fahrenheit. What would it be like to live on Venus? On Earth, seasons change because of the planet's tilt, but Venus doesn't experience any significant changes throughout the year. Things are pretty constant at night and during the day too. And what about the view of the sky? The clouds on Venus appear yellow or bright white. They're mostly made of poisonous sulfuric acid, but then why does Venus appear reddish-orange when you look at it from Earth? Talking about the true colors of planets can be a tricky business. The hue of a space body might be different when you look at it from another planet. If we traveled all the way to Venus, a reddish-brown surface would welcome us. The molecules of carbon dioxide and sulfuric acid block sunlight coming into Venus's surface, hence the reddish-orange color of the planet. Oh, and did you know that Venus is often called Earth's twin? Both planets are nearly equal in size. Both have relatively young surfaces and thick atmospheres with clouds. Plus, the orbit of Venus is also the closest to Earth. That might raise a question about the possibility of life on Venus. I'm sorry to break the news, but nope. Venus is not habitable. The next destination is Mars. Unlike Venus, Mars has seasons due to the planet's tilt on its axis. It also has a secondary seasonal effect caused by its highly elliptical orbit. The southern hemisphere has colder winters and hotter summers than those in the northern hemisphere. The average temperature on Mars is negative 80 degrees Fahrenheit. But temperatures can also range from the poles to the equator, and they can change very dramatically within a single week. Still, not that bad compared to the previous two planets, huh? Is Mars habitable? The number one thing a living organism should worry about here is space radiation. Earth has a magnetic field and a thick atmosphere to protect its surface from radiation. Mars has neither. The planet's gravity is 1/3 of Earth's. So, weaker gravity and a thinner atmosphere make it harder for any living being to survive on the red planet. In 2013, NASA reported an ancient freshwater lake that could have been a hospitable environment for microbial life. This is evidence now that liquid water once flowed on Mars. This confirmation suggests that Mars could have had the necessary environment to support life. But what happened to the water on Mars? The most popular explanation is that the planet's atmosphere became too thin and cold to keep liquid water on Mars's surface. The disappearance of water might also be related to the loss of early magnetic fields. Or the reason might be the red planet's size. Mars is probably too small to keep water. So, for now, Mars is not habitable. But, scientists keep sending missions to Mars. Maybe they'll find some new information. Let's wait and see. Now, Jupiter. Have you ever wondered what it might be like to live on the biggest planet in our solar system? Jupiter's environment is an unlikely place to support life. The temperatures on this planet and its composition are too extreme for any organisms to appear there. Jupiter has layers of gas, mostly hydrogen and helium. These gases fill the entire planet. Quite literally, there is no solid surface on the planet. Gases go all the way to the core, below the surface. They become liquid and turn into plasma because the atmospheric pressure there is way more intense than any place on Earth. To put it into perspective, an organism on Jupiter has to resist 1,000 times more atmospheric pressure than it would on Earth. Can a living being survive in such conditions? Unlikely. Jupiter is completely uninhabitable. But hey, have you heard that its moon Europa might be a possible habitable zone? Change of scenery. Saturn. It's the second largest planet in our solar system. Like Jupiter, Saturn is a gas giant ball, mainly consisting of hydrogen and helium. What about temperatures on Saturn? It's freezing. Plus, there are extremely powerful winds there. The winds in Saturn's upper atmosphere reach the speed of 1,600 feet per second. Let's compare them to storms on Earth to have a better understanding. The strongest hurricane ever recorded on Earth was moving at 350 feet per second. So the answer to the question, is there life on Saturn? Seems pretty obvious. Life, as we understand it, doesn't exist there. The next stop is Uranus, one of the largest ice giants. Uranus's atmosphere is dominated by ice, but it's not the only reason that causes the planet's blue color. It's also the methane in the atmosphere. It absorbs red light and reflects blue. The same goes for Neptune. Uranus is the coldest planet in the solar system. The temperatures there can be as low as negative 371 degrees Fahrenheit. Life on Earth needs sunlight to get energy, but there's nothing on Uranus that can produce any energy for life forms to thrive. The bottom line is Uranus doesn't have the environment to sustain life. Heading for Neptune, the second ice giant. What is there on the planet furthest from the Sun? Obviously, it's incredibly chilly. There's neither a source of energy that bacterial life can exploit, nor a source of liquid water. Currently, scientists believe it's unlikely to find life on Neptune because of such unfriendly conditions. So, what makes our planet so livable? And I'm not just talking about human life, I mean any living organisms, even microbes. Life requires very special conditions to exist. All living beings need some sort of food, water, and the right temperature to develop. The atmosphere is a vital element. Humans, for instance, need oxygen to breathe, and they can only survive in temperatures that aren't extremely hot or cold. Another thing is gravity. All the other planets I've mentioned don't have exactly the same conditions as Earth. Life there would probably be different than what we have here. All living beings on Earth have adapted to our atmosphere, and life forms elsewhere would need to be able to survive in that planet's conditions.